So we've talked about what projectile motion generally is, and that's when you've got some object falling only under gravity, being launched
Yeah.
at some velocity, at some angle, and it undergoes this sort of trajectory and then lands here.
Yeah.
Now, it will go up,
Mm-hmm.
and in the process get slower and slower and slower and slower
When the angle changes
until
accordingly.
it gets to the top,
Yeah.
and then it's going to then start going down.
Yeah.
So as a result of that, that means there is some point where it's at the highest possible point, and we're going to call that max height.
Your velocity will be 0.
And we're going to give that h equals 0. So not h equals 0, but we're going to call that max height h. Okay.
Okay.
And what do we call this horizontal distance?
Just horizontal
So it will be
distance.
launched into the air. It's going to drop back down.
It's
And this
yeah,
distance
it's using the formula.
Is going to be called
You
range.
get the horizontal component. Oh, okay, right.
So we're going to be talking about some terms, right? So you've got the terms max height and range. Of course,
Yeah.
terms that you should already know is that v is the launch or projection angle, projection velocity. And theta is the launch or projection angle.
Yeah.
And of course, for different velocities and different projection angles, we're going to get different trajectories. Okay, and the other thing, of course, is as the projectile moves through the air, time will pass, and then it will then hit the ground at some other time. And so the time it takes to go through the air and hit the ground is called time of flight. And we're going to call that
time of
t.
light. Oh, time of flight. Oh, okay, right. I was like time of light. Yeah.
So it's the time of flight. Now,
Yeah.
keep in mind, of course, that we've already talked about our 6 different equations. So we've got a horizontal.
Yeah.
Where we know that ax equals 0. We know vx equals ux, which is going to be v cos theta. And we've also got sx equals, well, uxt, which is vt cos theta. And for vertical, we already know that ay equals negative g, vy equals uy minus gt, which we can write as v sine theta minus gt. And sy must equal uyt minus half gt squared, which is vt sine theta minus half gt squared. So those are our 6 equations.
Yeah.
When it comes to maths, and when you do projectile motion in maths, which you will in 3 unit and 4 unit, then we would also represent these in terms of x. So I'll write the maths way we would write it in blue. So this would just be x, okay? X represents the displacement.
Yeah.
The velocity is the rate of change of displacement with respect to time, which is why it's represented as x dot, where that dot just represents the derivative with respect to time.
Yeah.
And then acceleration, of course, being the derivative of velocity with respect to time, means that it's the second derivative of displacement with respect to time. So you can just write that as x double dot.
Yeah.
And of course, there's similarly.
So would they, like in the physics exam, provide you the equation by any chance? Because
yeah, they will. They will put it in the data sheet, but you should know them regardless.
Okay.
So
no. I think like you know how for maths you could, if they give you the displacement in accordance to time formula, you could just get velocity and you could just get acceleration. Is there by any chance they will do that for physics?
In physics, all of the formulas are on the data sheet already, or 6.
Oh, yeah, Right.
but you should know them anyway.
Yeah.
All right. So very similarly, you've got y, which represents the vertical displacement, y dot, which is the derivative for velocity, and y dot for the acceleration. Okay, so you now have these 6 equations. We've got the physics and math symbols, but they really are the same thing. Okay, so now we want to use these 6 equations to then help us work out an expression for range, max height, and time of flight. And we'll be doing these one by one. But before we do that, I just want to stress, look at these 6 equations.
Yeah.
For a particular projectile motion with a particular launch velocity and a particular launch angle, what then is our variable in our 6 equations?
T.
Exactly. So these are equations in T. In other words, time. So for us to really be using these equations, we really should be focusing on T, time, okay?
Yeah.
So our job now, and these are very common questions as well, is we want to derive expressions for the time of flight, range, and max height.
Yeah.
And we'll do these one by one, all right? So keep in mind, of course, everything we've discussed. How do you think we would find the time of flight?
Only when we're on like it for what question though?
The question is very simple. You launch on level ground, we're going to assume level
Yeah.
ground. You are launching the projectile at velocity v at angle theta. What will be the time of flight?
T equals I'm not sure.
Right. So the way you do these questions, or any question, is you really need to be thinking about what you know about this point. Okay. So you have
you could
6
break
equations.
it into half.
So you have 6 equations.
Yeah.
Right? You've got your ax is 0. You've got bx equals v cos theta. You've got sx equals vt cos theta. You've got ay equals negative g. You've got vy equals v sine theta minus gt. You've got sy equals vt sine theta minus a half gt squared. Now, you need to think of what you know about this particular point, because that will then tell you which equation you want to use, right?
So at that point, v is 0.
You don't know that.
Oh.
Okay.
But isn't it on a level ground, so it gets hit?
Well, before that, it's not, so no, it's actually not v equals 0, because you're actually it's going to be landing with some velocity, right? And once it hits the ground, if you're going to talk about how the ground stops it, well, then it's no longer projectile motion once it hits the ground, right? It's projectile motion before it hits the ground.
Okay. Wait, could you break this parabola into half?
You could, but I wouldn't
Yeah.
recommend doing that because it doesn't work all the time. Okay.
Okay.
So while you can do that, that method would only work if it is level ground. And while I know it is level ground here, I don't want you to focus on that method, because then the moment it's not level ground, you can't do that.
Yeah. Okay. Yeah.
So with the fact in mind is we need to understand what we understand about this point. Now, we don't know. I mean, the acceleration is kind of known. And unless we do a bit of more work, which we could do, but I'll leave aside for now, we don't really know the velocity that it lands at, right?
No, we don't.
Not without doing some work, which I'm going to leave aside for now. Now,
yeah.
I want to find the time of flight. Do I know the range at this moment in time? Do I know?
No, you don't.
Right, so that means I don't know Sx. Now, do I
No.
know what the displacement in the y direction is?
No, you don't. The maximum height, right?
Well, I started here, right? Vertically, I'm ending here. So what's my displacement vertically?
your range, which is
Vertically, vertically, what
oh,
is?
vertically, sorry, your maximum height, which is v
Well,
sine
that is the
vt sine.
displacement at here, but between this point A
Mhm.
and this point B,
Yeah, that's
I'm
the
moving from
range
here
horizontally.
to
Mhm.
here
Yeah,
and looking at it vertically,
yeah.
what is my displacement?
Uh, it's mm,
Remember, displacement is a vector. So you just need to
yeah.
think about how far higher or lower B is compared to A. That's really the only question.
How far? Oh, 30?
Is B higher, lower, or the same height as A?
Same height as A.
If B is the same height as A, then the vertical displacement of B compared to A is just 0.
Oh,
It didn't go up. It didn't go down.
oh, so we're only considering at the endpoints, right?
Well, yes, because that's what displacement means, right? Between 2 points, what?
Oh, yeah, true.
The straight line.
Oh, yeah. I've been always thinking about how in the middle there's this huge gap of maximum height.
But that doesn't matter when we're asking about displacement.
Yeah, true. It's
Okay?
there.
And the range is irrelevant when we're asking for vertical. Right?
Yeah.
So the vertical displacement of B is 0. So we therefore know that Sy is 0.
Yeah.
So to derive the time of flight, it's actually very simple. We consider what we know, that is the vertical displacement is of B is 0. So we basically let Sy equal 0 and we solve for time.
Mm.
And that's basically how we're going to derive the time of flight. There's going to be a little bit additional detail afterwards, but let's go ahead and do that. So if we let Sy equal 0, we're going to get Vt sine theta minus a half gt squared.
Mm-hmm.
Now, this might look difficult, but it's actually not as difficult as it seems because you can factor out a t.
Yeah. When you perfect square it.
And if you factor out a t, and this times this is 0, that means you already have your two answers, right? Either t equals 0, or
Yeah.
this thing in brackets is 0.
Yeah.
Now, t equals 0 means at the start, which is here, and that's at A, which is on the ground, and that's true.
Mm.
But is that the one we're interested in finding?
No, we're looking at when
We want to
your
get to
B.
here. So that means
Yeah.
B must, the time of flight, which is when it's at B, must be the answer to this part, all right?
Mm-hmm.
So just quickly moving across, that means half gt equals v sine theta. Or in other words, t must equal 2v sine theta over g.
Yeah. You don't know V though.
Well, we're trying to give you a general formula for any v and any theta, right?
Oh, okay. On level ground.
On level ground, indeed.
Yeah.
So that means that with this sort of step, we know the time of flight for any projectile motion on level ground at any velocity v at any angle theta. Of course, it depends on v and theta, but at any v and any theta will just be 2 times v sine theta over g.
Okay.
Now, I don't recommend you sort of use this directly. I mean, it will be great if you're familiar with the fact it's 2b sine theta over g, both for physics purposes and for 3-note purposes. But most
Yeah.
certainly, I wouldn't expect you to be able to use it directly. You would probably need to derive it using the steps that we focused on. So it's very important for you to understand the steps we did, because you will need to use them yourself if you're not just given the product, the result. But the steps are more important than the result. But it would be great if you were familiar with the result, because then you know when you get the answer whether it's the right answer or not.
Yeah. Great.
Okay, so that's how we derive time of flight. Now, any questions with that?
No, makes sense.
So then that means the next one we're going to do is we're going to derive range.